So one final example of being able to work with our system of differential equations. And this time we have three tanks. And suppose we have a diagram where we have tanks A, B, and C. They're comprised of salt and water. And suppose tank A has a volume of 20 cubic feet, and then tank B has a volume of 40 cubic feet, and tank C has a volume of 60 cubic feet. And then assume the volumes remain constant, so we're not losing anything as this cascades. Let's define x1, x2, and x3 to be the amount of salt in each container, and then t to be time, and we could put it in minutes. Since pure water is poured from the first tank, we know that eventually all the salt will be eliminated. So finally assume that the water enters tank A and drains from tank C at the same rate, which is going to be 10 cubic feet per minute. All right, so lots of stuff going on there. So let's just say that that's the amount of salt x1 in tank A, x2 in tank B, and x3 in tank C. And we know that the rate of flow is going to be 10 cubic feet per minute. So going in is 10, and here is 10, and here is 10, and here is 10. All right. So let's go ahead and set up a system of differential equations, and remembering that input rate is equal to the output rate, which is equal to the overall rate for this. All right, we're not given any initial conditions yet. So for part A, we have three tanks. All right, so I'm just going to call this x1 prime. All right, probably not the best notation I could use. Now, the rate of salt in, all right, because we're really looking for the rate of salt. All right, now this is pure water, okay, so it has 0 salt in it, so that's 0 minus, now it says initially we have a volume of 20 feet cubic, and it's leaving, or the rate in is going to be 10 cubic feet per minute. All right, so this is going to be 10 out of 20, and I'm just going to call that x1 because it's leaving at that rate. All right, now x prime 2, what's coming in? Well, what's coming in is 10 out of 20 x1. And what's leaving? Well, remember we said that tank B has 40 feet cubed. All right, so that's going to be 10 out of 40, whatever the amount of salt is in x2. All right, and again, we're not given initial conditions, so let's just hang in there with that. It's theoretically just setting it up. And then finally, x prime at 3, what's coming in is that 10 out of 40 x2, and what's leaving? Well, I think we said 60 was the volume in tank 3. All right, so rate is 10 out of 60 flowing out of x3. All right, so that's our system. Okay? And in part B, we want to find the equilibrium solution. All right, so in part B, we're just going to say 0 equals minus 1/4 x or 1/2 x1. Right? And all I'm doing is I'm just simplifying the 10 over 20. 0 is going to be equal to 1/2 x1 minus 1/4 x2. And then finally, 0 is going to be equal to 1/4 x2 minus 1/6 x3. And so what does that mean for the equilibrium solution? In other words, when is the rate going to be non-existent or the change? So this first one, well, we just can clearly see that x1 is going to be 0. And if we substitute that back in here, that means that that term goes away. And that means that negative 1/4 x2 is going to be equal to 0. And that can only be true when x2 is equal to 0. And now you can see that this will produce the exact same solution, that x3 is equal to 0. All right, so the only possible solution to this system for equilibrium, in other words, when the rate is going to be the same for all, or it's going to basically say that no salt is going in, it's going to be at the initial point when they both have none in there. All right, so this basically means that no salt enters when there is 0 salt in all three tanks. All right, and again, that's a duh. All right, because if there's any salt in tank A or in tank B or in tank C, if we're flowing pure water in, eventually we're going to dwindle it down to get nothing. All right, so hopefully that makes sense for that. Now, for part C, now we have some initial conditions. All right, so tank A is going to have 30 pounds, tank B is going to have 50, and tank C is going to have 70 pounds of salt. So I'm going to copy this system, right, since we need this. And we have the initial conditions that x1 at 0 is 30, x2 at 0 is 50, and x3 at 0 is 70. Now, these are the pounds of salt. All right, and remember, the unit is minutes that we're flowing from. All right, so let's make sure we have these units square. So minutes and pounds. All right, so the salt, the rate of flow for the salt is going to be pounds per minute. All right, so now we're just going to use Wolfram Alpha, and we are going to solve a system. All right, so now I'm going to use X, Y, and Z instead of X1, Y1, Z1 just for simplicity. So X prime is going to be equal to 0 minus 1/2 times X. Y prime is going to be equal to 1/2 times X minus 1/4 times Y. And then finally, Z prime is going to be equal to 1/4 of Y minus 1/6 times Z. And our initial conditions, X at 0 is 30, Y at 0 is 50, and Z at 0 is going to be 70. All right, so let's go ahead and compute, and hopefully we get a nice, or maybe not so nice, but at least some values out of this, okay? And this is what we end up with, all right? So it's not a terrible system by all means, right? So I'm just gonna copy this over, all right? So, and by the way, this is part C, where we're solving this. So we're gonna say x1 at t, which is tank 1, is just going to be 30e to the minus t over 2. X2 at t is going to be equal to, I'm just going to distribute these out. So if you're playing along, you have this. So I'm just going to distribute the 10 through here just to make it a little bit easier on us. So that's going to be 110e to the minus t over 4. And then we're going to get minus 60 e to the minus t over 2. Right? And then finally, x3 at t is going to be equal to 45 e to the minus t over 2 plus or minus 330, excuse me, e to the minus t over 4, and then plus, I think it's going to be 355 e to the minus t over 6. All right. All right, so that's our solutions to this system. Not the nicest solutions, but they are what they are for us. Okay, so let's hold on to these. And now for part D, all we're going to do is apply this system or the solution. So in part D, we want to find the amount of salt in each tank after 12 minutes. So in reality, all we're doing is we're finding x1 at 12, x2 at 12, and x3 at 12. All right, and I'll just write the first one out just because it's the easiest one. So we're just going to have 30 to the minus 12 over 2. All right, and that's going to be approximately 0.0745 pounds. All right, so initially, now remember, initially there's 30 pounds of salt. So after 12 minutes, we're basically down to nothing. After 12 minutes, this is just going to turn into 5.328 pounds. All right, and then finally, we just plug in 12 up here. All right, so just plug in 12 for each of those, and that's going to yield 31.726 pounds. All right, so there's still a lot of salt in those tanks after 12 minutes, at least in the latter of the two. In the first tank, it's almost gone. So if I'm running the company or if I'm an engineer or something like that, I want to plot the solutions on the same graph and try to approximate how long it will take to contain almost no salt from the graphs. All right, so I prepared a graph. I just utilized Wolfram Alpha to do this. And I'm going to copy and paste the graph I got. I'm certain that you guys know how to plot these on a graph. Right, so let me go down here. There it is. Okay. And so here's our graph. We'll stretch it out just a little bit. And what we're looking for is we're looking for the points where there's almost no salt in here. All right. So if I'm looking at the first graph, all right, and remember, this is the graph for x1, this is x2, and this is x3. So this is the top of the amount of salt in each tank after time t. Okay, and that's in minutes, remember. Okay, and the salt is pounds. All right, so just making sure we understand what we're actually looking at. This is going to be our value for x1, x2, or x3. So this is the amount of salt, and this is the time. All right, so right here, it looks like that it's almost touching the graph. So for tank one, we could say approximately 11 minutes. All right, and that kind of makes sense because remember we found after 12 minutes, it was down to just 0.0745 pounds. So there's just a few traces of the salt part of the solution that's in that tank. Now for tank two, okay, maybe right about here, right? So what do we think, like 28, 29 minutes or something like that? I'll say 28 because I can. All right. And again, we're just approximating how long. And then finally, for the last one, somewhere like around here. So like what, 45, 46 minutes or something like that. All right. So tank three is approximately 46 minutes. All right. Now, of course, we could use Excel or we could use like some computer algebra system to help us. And we could just create a loop and it could just kind of process after each minute. All right. In fact, if I really wanted to, I'll do this really quickly just because I can. I could kind of create like a scatter plot or like a table or something like that that can kind of tell us how much salt's going to be in the tank after time t. So I'll just do this really quickly to show you all. And this is actually a good precursor to the next section because in the next section, we're going to start looking at using Excel to do numerical approximations for differentials. All right, so let's have our time and let's have amount in tank one just to show you how you might do this. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, not 102, 10, 11, 12, 13, 14, so just 14 minutes. And remember our first one, we had e to the minus t over 2. So in this case, it's going to be a2 divided by 2. All right, and it was 30 times that. All right, so at time 0, there were 30 pounds. And then, so after 1 minute, there's 18 pounds. After 2 minutes, 11 pounds. After 3 minutes, there's going to be about 7 pounds. After 4 minutes, 4 pounds. 5 minutes, 2.5 pounds, etc. And then if you really wanted to, you can make a scatter plot out of this. So we can highlight it We go to insert, and we can just go ahead and pick this scatter plot right here. All right. And this is actually a pretty good indicator. Remember, we guessed 11. All right. So it looks like 11 is actually a pretty good guess. 10 might be a pretty good guess too, 12. So somewhere in here, right? But certainly wouldn't guess 6 or 4 or something like that. You could do the exact same thing for the amount in tank 2. And again, just illustrating how you might do this easily. So remember, this one was equal to, we had negative 60 times e to the t over 2 times a2 over 2, and it was negative. And then we said plus 110 times exp to the minus a2 over 4, right? And remember, the initial amount was 50, and we could just drag it down. So after 14 minutes, there's about 3. Of course, if we wanted more, we could just expand this out. All right, so let's just drag it down to 40 minutes. And we could do the same thing for both of these. And we could just drag this down. All right. And notice right about here, I mean, we can clearly see, I think we guessed 28. There was only about 0.1 pounds of salt. So almost no salt in the tank at that point. All right. So just showing you guys how you can go through and use Excel to be able to help you to see what's going on with this relationship.